Hi, it's Adam the Hip Nerd, and today's show and tell is
this Z-axis upgrade for my Maslow CNC. Let me show you its features. Well, it's a beautiful day in the neighborhood, but not such a beautiful day for my Maslow. This happened again. The router slipped out of this clip right here, plunged into my workpiece, and I am done. If you've seen my other videos, you know my frustration with the Z-axis system on the Maslow. So I decided to build a project from the Maslow community called the Meticulous Z-axis, which replaces the router housing with a rail system. I ordered a rail kit from Amazon, which comes with bearings, a lead screw, and mounts. And after I received the parts and got the frame cut, I got to work. The Maslow community site has the CAM files for cutting the frame and sled, as well as the STL files for 3D printing the dust collection system. Well, it's a cold and rainy day here in Southern California, but I'm not going to let that stop me. Okay. So I'm going to line up all the pieces so I can kind of get a good general idea how everything is going to look and fit. So I'm going to start with putting together this carriage. And the trick is to be sure that all these rods are perfectly parallel to each other, and that the spine and the rods and everything are perpendicular to the sled. So that's the most important part. And I think I'll start by getting these bearings attached to the sled. This 3D printed part is for the dust collection, and I actually printed it on my old $160 3D printer kit, and it still works. There was a layer shift and it printed off, so I just snapped it off, and yeah, I think it was supposed to be like this, and I don't think I need it. Okay. Okay.
Yo!
Ah!
What up?
Hey man.
How's it going?
Okay. I'm just getting started trying to figure out how to put this all together. It's a little tricky. Tricky.
Walk around, that's right.
It's tricky. It's tricky.
Tricky. It's tricky.
I'm glad you know that song. Okay, so I think the thing to do is get one of these on and then put the rod through and mark the holes for the other one, and that way I'll be sure that it'll be lined up perfectly. I had a lot of issues drilling the holes and had to re-drill them for the first bearing. Using a drill press would have been better than using a hand drill. And I actually have one in a box, but have no place to put it as of yet. I also found that using a pencil wasn't giving me accurate markings, so I used a drill bit that just fit the holes in the bearings and dipped the tip of the bit in ink from a pen to mark the hole locations.
There's truth in that, because it's documenting this moment, and the poem really celebrates the artist, and it's really a special poem. And I wonder if you think about this in terms of your legacy in 1,000 years, in 5,000 years, people seeing your work and your signature and being like, oh, this guy.
Then I started figuring out the alignment of the parts on the spine. I did a lot of checking and double checking to make sure that all the pieces were in the right place before bolting them on. I 3D printed the bracket for the lead screw nut. If that turns out to be a weak point, I'll make one out of some angle iron. Since I didn't countersink the bolts, I had to cut some notches in the spine supports for clearance. I still had the old sled set up, since the last step in building the new sled was to transfer the ring system and Z-axis motor from the old one, so I used it to cut the acrylic window for the dust collection system. Then I used a rotary tool to cut the contour for the chute. I kind of expected it to be part of the file, but no big deal. It was finally time to say goodbye to the old sled and Z-axis. Then I cut a rail from an old 3D printer to make a connecting rod between the Z-axis motor and the belt pulley. Everything was going great, and then tragedy struck. Shit. That's... No! Oh, stupid. That's not gonna work. Okay, I can finally complete this project. I got this coupler to adapt the motor shaft to the shaft for the gear that turns the belt. Originally I ordered this thing, and this was the wrong thing to get because it has the coil on it, and when you put lateral forces on it, it bends. It was a mistake. Holding up the whole works. So this is solid. This will do the trick. So beyond the, adjusting the ground control software and doing some of the other stuff, this will pretty much finish up the physical build. I'm a little nervous, but plowing forward. The new Z-axis system sticks out a lot more than the old one, so I changed the height of the ring system to compensate for the change in the center of gravity. I figured out the pitch for the lead screw and dove immediately into my first test, cutting one of my CNC halftones, which uses a lot of Z-axis moves. There was still an issue though. So I thought I had this problem solved, but apparently I don't. As you can see on my 3D halftone here, the holes on the right side here are a lot bigger than the ones on the left. There's some kind of problem that maybe it's mechanical, maybe it's software. So first of all, it cuts the pattern, goes down and up and down and up, and it cuts the holes going this way. So perhaps it's accumulating some kind of error, and by the time it gets to here, that error has accumulated to the point where it's drilling way deeper than it should. And I thought the problem originally was with my old Z-axis, and that the slop was accumulating, but this new Z-axis assembly should have eliminated that. I mean, this thing is really solid. It doesn't feel like there's any slop in here. So I don't think it's mechanical. I'll have to go and check the gears here and make sure like nothing is slipping, but I'm pretty sure that's not the problem. I checked the file. It's not in the file, although the file does have one peculiar issue, and I took care of that, so maybe it's that. So here's the deal. The holes over here, they should be about 0.09, 0.8, 0.08, 0.07 inches deep. And the ones on the right hand side are about the same depth, so they should match one way or the other. Even if they're not accurately to that depth, they should at least match between the different sides. The file confirms that these are about the same, but the file does have one thing. Since I generated it in software, there's a level of precision that's kind of ridiculous. It's like 16 decimal places. So maybe somehow that's screwing up the other software, maybe ground control, which is software that's used to control the Maslow. Maybe somehow that's getting screwed up by having in like that level of precision. So I changed it so that it's just 4 decimal places, and I made 2 test files. One that cuts horizontally across, so it's going to be a pattern of 30 by 30. It's going to be a grid of holes, 30 by 30, and it's going to cut across this way. Then I have a second one that does the same thing, only vertically. Now I would expect that vertical one to come out looking like this if the problem's mechanical, since that's pretty much simulating the same thing. So all the holes should be the same depth, And if the problem is like an accumulation of mechanical issues, it should go up and down, drill the holes, and by the time it gets to the right side, it should, be drilling these holes a lot deeper. With the other one going horizontally, I would expect to see down at the bottom right the holes getting deeper. We'll see. We'll see. I don't know. Maybe it's the precision thing. Maybe it's some kind of mechanical issue. We'll run these tests and we'll find out. I'm going to consider this, unfortunately, a piece of scrap now, so I'm just going to flip it over and drill on the other side. I may spray paint it black because I think that shows the contrast pretty nicely. It'll be easy to see whether the holes are coming out the right size or not. And here we go. And here's the test pattern, and I'm pretty sure that what this test pattern reveals is that the surface of the plywood is not flat. And what is happening, as you can see, the holes get smaller as they go to the right, and it drills them this way. And they also, they get bigger as you go down, and you can see like small holes up here, bigger holes down here, and I think that's just because the wood is a little raised in this area and lower in this area. And another indication of that is actually a mistake I made when I made the file. When I made this test pattern, I altered another program, the one that does the CNC halftone images, and the traversal height in that program was 0.125 inches, or 1/8 of an inch, and I forgot to change the traversal height, so the height was the traversal height was 0.125 millimeters, and you can see in the high areas where the holes are bigger. Well, this was the last pass of the machine from this corner up here to home, and where the holes are smaller, it passed over without a problem, and the holes start to get bigger as it goes up this way, and it starts digging in. So that whole distance, the bit's not changing height at all, and what's happening is this is like warped a little bit. And down here, I'll zoom in, you can see similar things here. Since it's traversing this way, you can see as it gets to the higher ground, it starts digging in a little bit, and you can see lines between the drills, the holes. So yeah, I think the best thing to do at this point is to just screw down the edges of this plywood so that it's as flush as possible with the spoil board. And the relief in that is that I don't think this thing has anything to do with the problem at all. So I'm going to flip this around, put this at the top, or maybe I'll just leave it here and cut this area. I think I'll, instead of redoing this test pattern, I think I'll redo the butterfly halftone. And that way, if it comes out good, I'll at least have something to show for it. And if it still doesn't come out right, well, I'll just go back to doing more test patterns. I can do another one up in this area. And so, yeah, here we go. All right, well, that was a really successful test of both my new Z-axis and my approach to making these CNC halftone images. So what I discovered is indeed this wood is a little bit warped. I probably left it sitting around a little too long, and we had some really rainy days here in Southern California. But in any case, when I put this straight edge and press against the right hand side, I can see that there's like a good 2 millimeter gap here on the left. So this side of the image is 2 millimeters lower than this side, which makes the dots here a little bit bigger. What I did is I made the overall size of the dots greater so that the difference will be less apparent. And you know, if you look really carefully, you can see these holes are a little bigger, but I think visually it still looks really nice. So in the future, I'll just be sure to compensate if I have any warpage in the material, and just try and use flatter material. Certainly one thing I could do is I could use a large router bit and just run it across and level the wood that way, but I really wouldn't want to have to do that. I think for all intents and purposes this is fine. I'm really happy with the way this came out, and I'm really happy with my Z-axis upgrade, and yeah, so I guess I'm really happy is what I'm saying. Alright, thanks for watching. When I walk down the street, seems everyone I meet gives me a hearty hello. I guess I'm just a lucky so-and-so.